once we have opened Ansys Workbench, see here there is a cross sections group that has been added to the outline tree, which contains the information of the eye cross section which we have applied to this steel frame, and the dimensions of this particular eye cross section are given here. So once we have verified that the eye cross section has been applied to this frame, I'm going to just right click and say mesh, and once I generate the mesh, I'm going to apply the boundary conditions as well as these forces, and I try to solve this particular problem. And here I may encounter one commonly encountered problem which is known as the solver pivot error. We will see how to reduce that particular error. For now, what I'm going to do is I'm going to right click, say insert, and I'm going to go to the fixed support, and I'm going to select this 6 points, so 6 vertices, and I'm going to just press apply. So we have given the fixed support. Now what we need to do is we need to right click on the static structure, say insert, and we need to insert a line pressure. So where is here is the line pressure. So we have to apply the line pressure. So you need to select this particular line and say apply, and you need to change the defined by to components, and in this you are going to give minus 50 E3 because the load was minus 50 kilonewtons per meter. See here, if your units are not in meters, you can go here and change your units to meters from here. Okay, so once we have given the line pressure, what we are going to do is we are going to just right click and say copy this line pressure, and we are going to paste it. So we have to paste it for 7 times. So I have pasted it for So once I paste it for 7 times, now what I'm going to do is I'm going to select this line pressure, I'm going to select this particular edge, and in that I'm going to change the edge selection to this one instead of this one. So likewise I'm going to change the edge selection for every line pressure and select other edge. So I'm going to just select this one, and so once we have selected all the required edges, I'm going to select all the edges at once, and I'm going to see whether there is an overlap or not. So right now we don't have any overlap, so we have applied the forces correctly. Now what I'm going to do is I'm going to just right click and say solve. Once I click on solve, the problem is going to be solved. And see, as I told you, there is a solver pivot error. It is being shown here. So whatever the error is being shown, you can just go to the message branch or message tab, and you can just double click on this in order to see this particular warning. So it is showing that solver pivot warnings or errors have occurred, and there are different reasons for this particular solver pivot error to occur. Generally what happens, the first and foremost thing is you haven't given enough constraints to the model, but in this particular model I think I have given all the required boundary conditions or say constraints. So that may not be the reason here. The main reason here is that we haven't created contacts between these line elements. Generally what happens, if this particular line models are created inside design modeler, this Ansys mechanical will effectively create the contacts between two or more members, between the members. But as this particular model has been imported from other geometric CAD system, what we need to do is we need to create connections between all of these particular beams. That is why it is showing a solver pivot error. For that, what we are going to do is I'm going to just click OK, and I'm going to just minimize this, and I'm going to go back to geometry, and I'm going to double click on the geometry, and once again I'm going to open this design modeler. And once I open this design modeler, what I'm going to do is instead of manually creating for every point like this, manually creating connections, I can just select every part, all the 26 parts, and I can right click and say form new part. So what happens, this all 26 members will be acting as a part of a new single body. Then what happens, the automatic connections will be effectively generated by this Ansys mechanical only. So once I have done this, I'm going to just close the design modeler once again, and once I close the design modeler, I can just right click and say refresh, so that the data that we have changed in the geometric or design modeler, it will be updated in the Ansys mechanical. And once this particular update is done, then we are going to open this Ansys mechanical, and then we are going to try to solve that particular problem. So right now what happened, the refreshing has done. So what I'm going to do is I'm going to just switch to Ansys mechanical. So now we switch it back to Ansys mechanical. Now what I'm going to do is I'm going to just right click and say solve. And if I press solve, now what happens, see, the solver pivot error will not be occurring, because all the joints between these frame members have been created successfully, and we got the solution. And once we got the solution, we can just right click and say deformation, and in the deformation we can see directional deformation or total deformation. And we can also see, I'm also just going to insert, go to the beam results tool. So in the beam results tool, I can see what are the axial forces that are occurring in a member. So here I'm going to select this particular member. I'm going to press apply, and I'm going to right click, say evaluate all results. Once I say evaluate all results, so in this particular member, it is being experiencing an axial force of minus 10423 newtons, or we can convert the units, we can change the units also, no problem. Okay, so if I just right click, say insert, and go to the beam results tool, and if I say bending moment, and I just select this particular instead of all bodies, if I just select this particular member, I can just apply. And now what I am going to do is I'm going to just say evaluate results. Once I evaluate the results, so this is the amount of moment that is being experienced by this particular member. Likewise, you can select any member, or otherwise you can also calculate all these results for the total members. So I'm going to just right click, say insert, I'm going to go to the beam results, and I'm going to go to this torsion moment. Once I go to the torsion moment, here every body in this particular geometry has been selected, so I need not change anything. I'm going to right click, say evaluate results, and once I evaluate the results, I can get this torsion moment for the total body. Okay, so this is how you can use the different beam tools that are present inside Ansys Workbench to solve 1D problems. In the next lecture, we are going to see how to solve a problem which contains both 1D as well as the 2D surfaces, which may be called as a hybrid model using Ansys Workbench.